Hey everybody, welcome to another episode of the Compile Swift podcast. This is a very special episode. I have Gio Lodi with me today. We are going to be talking about testing, and he has a new book coming out on testing, especially for Swift and SwiftUI, that I have been very privileged to take a look at, and I learned so much that we thought we got to get together and talk about this. So hey Gio, how you doing? Introduce yourself, please.
Hey, Peter. How's it going? Thank you for having me. Hey, everyone. I'm Gio. I am working as a mobile infrastructure engineer at a company called Automatic. Not many people have heard of Automatic, but you are very likely to have heard of the products that we work on, such as WordPress.com, Tumblr, WooCommerce, SimpleNote. And as a mobile infrastructure engineer, my role is a bit lower level than product development. Myself and the team that I work in, we help teams ship good code on a schedule. And part of why I ended up in this position is my long-time passion for testing, and in particular also test-driven development, which is, we get to talk about it a lot soon, but it is this way of writing code using the tests as the feedback mechanism, not only to give you an idea whether or not your code is correct, but really inform the design decisions that you take.
For those who don't know, would you like to go ahead and explain what this testing is? I think we'd all like to think that we all do testing, and we all say when someone asks, oh, yeah, I write tests. But, explain for those who genuinely admit, I've never done testing. So what are we talking about when we talk about software testing?
Okay. Well, let's start first principles, right? Even when someone says, I've never done testing, I don't know how to do testing, I would say you may think you don't know, but you actually know how to do it, and you've been doing testing for a long time, basically since your first program that you ever written. Many people start with an hello world. So you would write your hello world and then run it. And the act of running the code that you wrote and see if it prints hello world on your terminal or wherever you're directing the output, that is a test in itself. Testing is nothing more than verifying that the piece of code, the software that you have written, behaves the way that you expect it to. Now, the hello world example is very straightforward. Let's make it a bit more complex. Let's say that you have an optional input parameter to your hello world function. And if you say hello, you run the script hello world and you pass it a name like Peter, it's going to say hello, Peter. Otherwise, it's just going to say hello world. Now we have the behavior is a bit more involved. So to test to manually test rather this new iteration of our amazing Hello World program, you need to first run it without any argument, and then you would run it with like an input like Peter and make sure that the input comes out, right? So see, if you do this manually, you would, just as we said, you run it and then you check it with your eyes, and then you run it again typing Peter, and then you check it with your eyes to see if Peter came out. This works, and it might seem like a good approach for a simple program like Hello World, but it gets way more involved as your program evolves from an example script to an actual application. In particular, when you add, maybe you want to modify the behavior of a screen that is 3 steps down into the navigation hierarchy. So you make your change, you need to spin up the app, tap to go to your screen and check it. And again, you're checking it with your eyes. And this is, look, I'm lazy. This looks like a lot of work to me. So I was thinking, is there a way that I can shortcut this work? And that is where automated tests come in. And this is why I say that if you're a software developer, even if you've never written a test, you know how to write a test, because I would say all of our software is not run by us, the users. Actually, running the software is run by layers of other software. Like when I press my screen, there is a lot of hardware that translates the change in I think the let's say electromagnetic field in the screen down to like a information that the processor sends through and yada yada yada. And at some point the OS software receives a call, and then the OS software calls my app, and my app sends the event down to the view controller or the view screen, So software is already called by other software. And the jump from having the operating system calling your software for you as a result of you touching the screen and you writing another bit of software that calls your software for you is very tiny, because you already know how to write software.
As you were saying that, and as you were describing the flow, and I was thinking about, when I'm writing code, and that we get very focused on our code and we tend to forget the system part, right? And I think that when we're looking at writing our tests, we also have to remind ourselves that, the system will do what the system's going to do. And there's no guarantee that that's correct. But am I right in thinking that our testing is really looking at it and saying, okay, I need to make sure that my part is good. And if something else goes wrong that's related to the system, okay, I can't fix that, but at least I can identify it wasn't my code. Does that make sense? Is that kind of the way to look at this?
Yeah, I think that's a great perspective. And my attempt to describe what happens when you touch the screen clearly showed that there's so much involved, and that is very hard for an individual to know all the components. I certainly don't know how all those hardware levels work. Being able to validate that your bit of software works correctly is certainly helpful in then taking the next step and say, okay, you reduce the surface area in which you then need to continue to research for an issue when an issue arises. And it's also useful to know, hey, my software works correctly. Maybe you can. This is another kind of test, sometimes called, it can be referred to as exploratory test, or there's another name for that escapes me right now. But what I'm trying to say is you can write a test that wraps a third-party component or some OS feature, and you verify that it behaves in this way that it is not what you expect, but at least you have the test as a written compiling specification of the actual behavior. And then maybe that behavior that you weren't expecting is actually a bug in iOS. And you have the test that proves it. And when a new version of iOS is released, you can run the test automatically and see if they fix the bug. Because if the test now passes, for example, then the behavior is what you were expecting and the bug is fixed.
That's a really good point, because I know that when I've been discussing with some developers that I work with, and, we talk about testing, and of course the natural reaction for every developer is, I don't want to have to sit, I've written my code, and now you want me to write a test to prove my code. But I think that repetition is so important, because like you say, if you find that something, a test that was failing and you didn't change any code, but a new OS release came out, it's an indicator that maybe something under the hood there has been fixed. And that's a good point. And I think that also the repetition of these tests, and by writing them, I feel there's a real benefit that I can then hand those off and they go in the code base, in the repository, so that my fellow team members can also run those tests. If they have some questions about my code, they can look at the test and maybe that answers it as well. Because, the other thing is, if we all be honest, right, do we fully document our code for the benefit of the other people? Well, yeah, 6 months from now I will, right?
Yeah.
But also because if the code, what I like about this is if the code changes in some way, be it me or somebody else, and a test that was passing is now failing, to me that also feels kind of like an indicator that that block of code, whatever it may be, that I felt was isolated unto itself, clearly isn't, because something else has influenced it. And so being able to sit with the team and run those tests and say, there's something going on here. Somebody did a commit that's broken my test. We got to figure out who needs to do the fix here, right?
Yeah.
Also, when you commit, and that's the other part here, is when you commit and push to the repo, to have something where it can automatically run those like a test report for you all the time, I would imagine is very beneficial as well. Right?
Yeah, absolutely. There's so much to unpack in what you just described. So much that I don't even know where to start. Let's say, so you touched on the developer who says, I spent all this time writing my code, and now you want me to write a test for it too. I have a few things to say to this hypothetical developer. I would say, hey, first of all, if you write a test for your code, it is easier to verify that your code works rather than trying it through the application. Because I'm going to assume that they did try their code through the application to make sure that it worked. So if you write a test, it is going to be more efficient. So like you're going to told me you were upset because you had to spend more time writing the test. Well, if you had written the test, it would have been easier to verify the behavior. So you would have saved time rather than running the app. And then I would use the opportunity to introduce the idea of writing the tests first. So there's this, look, it's a bit of a strawman argument, but I like to make it anyway, which is you can't trust a test that you've never seen fail. So say you write your good implementation, and then you write a test for it, and the test passes. Most likely you've written the test properly, and the test is giving you a good judgment on the behavior of your code. But there is a chance. There's always a chance that maybe the test is asserting the wrong thing. You are calling the wrong property, and so like the value, the test passes, but the code is incorrect. So what you would need to do to really be sure of the quality of your test would be to change the production code to simulate a failure intentionally and see if the test can catch it. Now, this is even extra work to give you trust on your test. Now, if you spin it the other way around, where you first write the test and then write the code that test is verifying, in the first time that you've written the test, but the code isn't there yet, the test is going to fail for sure. And then if you keep adding little bits of code and the test fails, you verify in real time as you add the code that your test is trustworthy, that is telling you when the code doesn't work the way that you expect it to. So that is, I think, a very a good argument for the value from a point of view of the trust that we have in our test suite for writing tests first. And then it's a segue in testing and test-driven development in particular as these two phases. One is, it gives you confidence in the quality of your code from the point of view of the behavior. My code does what I expect it to do, but also the act of writing the test and following the test failures to shape the code that you are implementing, that is a great advantage in how you can approach the design of the code. Something that I say in the book is partition problem and solve sequentially. So when you're given a problem, the fact starting from the test helps you apply this principle, partition problem and solve sequentially, because you have a certain involved behavior that you want to implement. And you can start by writing a test list, which is nothing but the names of the tests that you want to run. If we go back to our hello world example, it would be hello world with no argument prints hello world, and hello world with argument prints hello given argument. And now, even just this exercise forces you to dig deeper into the specification that you've been given to understand what the code is supposed to do. And then from there, you've partitioned the problem. So now there's two behavioral hedges that you want to implement, the one with and without the input parameter. You can solve sequentially. You start by making the first behavior work, and you get that working. Good. Now the test is passing, and you can take a take a breather and be happy with what you've done. And now move on to the next one. You solve them sequentially. And this, I find, frees up a lot of my mental resources to really focus on one thing at a time, do that thing well, and then move on without trying to being a perfectionist and doing it good the right time. Because we all know that we all should know that the first time is seldom the best one. We need to iterate on our software and on our ideas, but still it's hard to let go of that. And you just want to, well, I'm doing it right, so I want to do it right. Instead, adding this structured approach, aided by the feedback of the test, to really move in an iterative way, I find it invaluable.
Yeah, I agree. I think, as I was working through your book, and one of the things it taught me very early on, which I realized that I had been trying to do it, but I was failing because I wasn't thinking about it the right way. And as you say, in your book, you focus on this idea of, break things down into small, chunks of solvable problems, and, by all means make an outline for the bigger picture. But when you're writing the code and when you're writing specifically your tests to then make you write the code, to go in and say, okay, each one should do one thing. And once you've solved that problem, move on to the next part. And I think it's a good example, like you say, for a Hello World program where, okay, the first test would be, print Hello World. That's it, right? We just call a function that's what happens. Next test would be that function plus an argument to put a name in, hello Gio, something like that. And that was one of the things that I really, for me, made the testing idea click when I was reading the book. And after working through, sort of the first part of your book, I realized the problem was that I didn't know the right questions to ask when I was writing my test or trying to figure out what the test was. And so that would naturally lead to me writing code which did what it was supposed to, but I wasn't really solving the right problem. Does that make sense?
Yeah, it does. Well, thank you for sharing this story with me. It really makes me happy to hear that the book helped you. I've been talking about testing for a long time. People that work with me, he's the testing fact, the guy that never stopped talking about testing. And it happens when someone says sorry, but I know I should write tests, but I don't do that enough. And I say, well, you don't need to be apologetic about it. Something that I try to explain in the conclusion of the book is you don't need to do test-driven development to have a good software design, because all the principles that test-driven development helps you implement, they are staples of good software design. Probably everyone is already familiar with them. The thing that I would just add is test-driven development can help you. It nudges you towards writing code in as respect the single responsibility principle that applies the dependency inversion principle that uses proper dependency injection, and that is composed of small, loosely coupled, highly cohesive elements and components. So I'm very passionate about it. It's the way that I like to work. I do think it's the air quote best way, but some folks may get really have very strong feelings about it, and they won't listen. Like it is a test-driven development or go home. I hope to come across less of an extremist and more like it is practice. It really works well for me. I apply to most of the code that I write, but sometimes it might not be the best tool for the job, or it might just not click with someone, and that's okay too.
When people think of testing, they think, oh, well, surely that's something that teams of, more than one developer working on something should be doing for good reasons, but that's not me, and I don't have to worry about that. Even if I'm just a solo developer on a project and I know that nobody else is going to touch the code base, writing tests is helping the future me to remember why I did this crazy thing to begin with. Because I think if we're all honest, we've done it, right? We write something, we ship it. 6 months later, we got to make a change. And you're looking at it and you're thinking, why did I do it this way? Why would I call that thing whatever I called it? Why would I do this? Why is my function doing 4 different things? And those tests for myself help me stay honest to the future me who's sitting there at 2 o'clock in the morning and just wants to go to bed, right?
Yeah. I think we don't have enough empathy for our future selves. You know, when you plan your week, or like when you are imagining, okay, I'll get to that later. Like, I'm going to be able to do all this stuff. And you're just overloading your future self with work. And it's the same with code. Like sometimes we may be too confident in the mental capacity of our future self, or in our future self ability to remember what we were thinking on a given day. And as you say, like when you work as a solo developer, that is really cool, because when you work in a team, like you can maybe no, it was that other person, I'll blame them. But when you're just by yourself, you got no one else to blame. And if you written code that you can't understand, it was you. Or it was your past self, I should say.
Because you never see like a Git blame. It was me, right? I'm blaming myself. That never happens, right? Yeah.
It's very humbling to find out. Look through the Git and I actually made this mistake. So
I put my hands in the air and say I've done that, and then I go back and I look and I'm like, okay, I think I see why I did this, because I just wanted to get the build to work and go home. But now I'm looking at it and thinking, boy, I wish I could wind that clock back, So there's that. Yeah. Something that, so moving sort of onto what I found was a key area for me in the book is, now that we've got this new world, right? I think of it in 2 ways. We've got our Swift, which is kind of the business layer and models and everything else. And then now we've got this SwiftUI that Apple has essentially said, look, we're not forcing you to do it now, but in the future, we're going to tell you to do this. As we're trying to wrap our heads around SwiftUI, and, personally, I really like the way that I can build my views, but it is still a mystery to me in many ways how I link my code and my views together. So if you don't mind, you have these chapters in the book where you talk about testing SwiftUI, and I'm really curious what situations and what problems you have found and how you overcome those as you look towards automating testing for SwiftUI, because this is an area that I've not touched yet. I know I'm going to have to, and I think you're going to save a lot of trouble for a lot of us by the way that you have in the book, because it made sense to me. But would you like to talk about that and the complications with SwiftUI for testing?
Yeah, sure. I think most iOS developers today have a UI kit background. There haven't been enough newcomers in the industry that started fresh with SwiftUI. One, because the framework is still in its very early stages, so adopting it in version 1, like, it was a bit of a gamble, and also the constraint that it was it depends on the iOS version. So even when you create a brand new app, there's always a case to maybe support the previous version of iOS. And I think that case becomes stronger and stronger. Apple has shown us this year that the same devices that support iOS 14 are going to support iOS 15, if I'm not mistaken. So there is a case to think, users might be a bit slow to upgrade. Although now that I realize what I've just said, the same devices that support 14 will support 15. So hopefully they will upgrade too, so let me rephrase. Apple is trying to help users upgrade, but there is still a good chunk of users that is on an older version of iOS.
Yeah.
regardless of the rabbit hole in which I dug myself, trying to get up. Adopting the new technology straight away is a bit of a gamble, and there are some technical limitations that for which you may not want to do it. So to go back again, most of us have this UI kit background, and the UI kit and SwiftUI, they work very differently. And trying to apply the same patterns and techniques and strategies to implement software for UI kit, trying to apply those same strategies to SwiftUI doesn't really work because it's a different paradigm. And it took me quite a lot of time to really grok that and, in a sense, let go of some of the things that I was used to do with UI kit and say, no, I don't need to do them in SwiftUI. This is really the key. SwiftUI makes a lot of things easier. Just a quick introduction for everyone that might not have the time to try SwiftUI yet or watch the great introduction talks that have been published at WWDC. SwiftUI is this declarative. SwiftUI is a framework that you can import, and it offers a declarative DSL for to build our views. The key difference from the UI kit approach is that in SwiftUI, views are a function of the state as opposed to a sequence of events as they were in UI kit. So whereas in UI kit you would instantiate an object, your custom button, then you will call a bunch of methods on that custom button to configure it, and you would change its state. In SwiftUI, you build a state value type, and you declare in the view how the view should configure itself based on that state. You really have to play with it and make some experiment to appreciate how it works in the details, but at a higher level, views are just in the same way that you might have our hello world function and you give it an input, and every time you give it Peter, it's going to say hello Peter. Every time you give it Gio, it's going to say hello Gio. That's the same thing in SwiftUI. You describe your view, and every time you give it your input, like button title text equal pizza, is always going to render on the screen in the same way. In the past, in UI kit land, I would encourage writing some level of using test-driven development to do some part of the implementation of custom views, or writing tests at the view controller view layer to make sure that when a certain button was pressed, this certain action was going to happen. This is not necessary anymore in SwiftUI because of the user function of state approach. SwiftUI guarantees you, hey, if you play by the SwiftUI rules and you give me a value type with this state, I'm going to render it the same way all the time. And this is the mind-blowing difference that when I grokked it, it really turned the proverbial light bulb. It was, okay, well then I don't need to write a test for the view configuration. I can simply use Xcode previews to iterate and just play around with my layout, with how it should look like, how it should render. And once that is done, I can put all my energy into using test-driven development to implement the pure business logic that produces the state value type that I feed the view, that I configure the view with.
I went into SwiftUI thinking to myself, okay, I've spent all these years with Swift and things like that. This is going to be easy because I'm pretty good with Swift. And then the problem became that I was fighting the system because I wanted, I had my preconceived notions, like you say, from UI kit. And then you go into Swift and you're like, okay, well, come on, do that. And it wouldn't do what I wanted, or it seemed like it wasn't doing it. And it's because I was expecting it to do the way I wanted it to happen, rather than throwing out what I know and accepting, all right, SwiftUI, you got this. I'm going to do what you tell me to do. And then as soon as, like you say, as soon as you grok that and you realize, oh, yeah, okay, the view, once it's on the screen, it's a static thing, right? And I think the clue I should have looked at it and gone, oh, well, the whole thing's built from a struct. That should have been my clue right there. And then once I realized, okay, so my view is essentially a static on the screen. If I want it to update, I've got to tell it something else to change so that SwiftUI then says, oh, got to update the view now. I'm going to rebuild it for you.
This is the unidirectional data flow idea. As developers, we don't have a way to force a re-render of the view. So we don't have a direct way. We only have an indirect way, which is provided with new input. And we can do it in different ways. The one that I explore in detail in the book is by using an observed object. Mm-hmm. So we use the observed object property wrapper to declare that a certain observable object that we pass to the view at initialization time is something that this is amazing as well. Like all the plumbing that the SwiftUI and Combine team have implemented for us by default. So what observed and observable object do together is every time one of the one of the properties that are wrapped with the published property wrapper of the observed object, every time one of those updates, automatically the view is going to re-render. And there is so much code under the hood that we would have to write to make that happen, or third-party frameworks that we would have to pull in to do all the dynamic bindings to make that happen. And now this automatic happens through SwiftUI and Combine and their seamless integration. And it's very beautiful. And again, as someone that likes writing tests, the least test I can write, the better, because wherever there's code, there's the possibility for a bug. So if I don't have to implement that anymore, first of all, it saves me time, but also there's less chance that I'll make a mistake. So that's just great. This transition that we're going through reminds me of the transition we went through from Objective-C to Swift. When if I remember correctly, when Apple introduced Swift, one of their taglines were Objective-C without the C. And I wrote, and I saw a lot of apps written as like a 1-1 translations of Objective-C code into Swift, sometimes with semicolons at the end too, this kind of stuff, right?
I still put semicolons sometimes. Yeah.
It took a while to become familiar with the language, with the difference, and with the Swift way to do things. And it's a learning progress. We just need to accept that it's going to take some effort, some repetition, some experiments, and some mistakes.
Yeah, you're right. And it's interesting that you mentioned, so many times when we go looking for things and we find solutions, and someone will always say, like, here's the Objective-C version, here's the Swift version. And, sometimes you can tell that they've kind of done a 1-for-1, switch out, which probably works. But I think the problem with, if you're a new developer or someone who's, sort of going into Swift and, we all copy and paste code. Sometimes, in particular with Swift, you don't want that 1-for-1 conversion because there could be something in the foundation that will do this for you, but it'll be very different code than just a 1-for-1 translation of Objective-C. And so I think it's important when, folks are doing that, this kind of updating of their code, that they go look and see, is there a better way to do this? And Apple is really good at this year on year, like this year with so many APIs and things like that, the async await and all of that kind of stuff, where it's like, look, you can write less code if you just do it this way, but understand why it's doing it this way, not just put it in, because if you have to then change it, you can be in a world of hurt. So I think it's important to understand anytime you find a solution from someone, make sure that you know what that solution's doing. Don't just put it in and great, it's fantastic, move on, especially if you're writing tests, because how are you going to test code that you have no idea what it means, right?
Yeah, there's something to dig into, which is Kent Beck he is the person that introduced the idea of test-driven development. Although if you were to ask him, he would say that he rediscovered it from a paper that he read at some point that was mentioning that back in the magnetic tape programming days, so a long time ago, they would write the tape the way they assumed the output, they expected the output to be, and then code their way until the output that they produced matched that tape.
Oh, interesting.
And which is, again, it is the idea behind test-driven development. I write the test that is going to pass when the code does what I want it to do, and then I write the code that makes the test pass. So Kent Beck has this saying, which is make it work, make it right, make it fast. And it ties very well with test-driven development, because once you have your test and you made it pass, you can play with the code. You can iterate on the code. You can change the code as much as you want and quickly get a feedback whether your change was left the code correct through the test. If you run the test and they're still green, then your code is fine. And this is actually the test-driven development mantra, the test-driven development flow. Red, a test that doesn't work, a test that fails. Green, a test that now passes because you built the code that makes it pass. And then refactor, reshape the code, change. The word refactor, or the verb to refactor, means to change the factor of the code. That is, change the way the code is shaped, the way it looks, without changing the behavior. That's exactly what the test allows us to do, because the test ideally should really focus on the behavior of the code, not its implementation. So if we change the implementation and the test is still green, it means that the behavior it is still correct. So it is fine if you write your test and it's failing and you need to make it pass and you don't know how. You may find some code on Stack Overflow and paste it, and now the test is passing. Great. Pat yourself in the back because you made the test pass, and now you can take a deep breath and shift your mind from, okay, I need to make the test pass, to I need to make the code right, from making it work to making it right. And you can change it in the, going back on the, it's a bit old by now, but anyway, because hopefully few people copy code from Objective-C and just want one translated into Swift. By now, most of the examples online are into Swift. But anyway, you have some Swift code that is not Swifty. I don't know, maybe it is using any instead of a certain type. It's not leveraging the type system. You can then reshape that code to be more in line with the better leverage the tools that Swift offers us, and just quickly iterate on that and experiment, because you have the test that give you these safety net. And again, you can do all that without test by running the app and verifying it manually, or like by being your own test runner and just looking at the code and trusting that is working in the mental representation that you have. I don't trust myself to do that. I'd rather have the test do that for me.
Yeah, me too. It's funny because I've had this conversation with some folks where, you know, they would have a problem with something and they were trying to figure out. And so we'd look at it and then we'd have some ideas. They'd go away and try it. And then they'd come back and it'd be working. They'd be like, great, we solved it. And then, you know, they send it off to code review and it goes in and somebody else passes it. And then I see the emails come in from like Jira and things like that. And it's like, oh, okay, I'm curious, really curious to see what their solution was. And then you go look and I see, like you say, they're like, well, they just typed it to any. And there's like a huge red flag of like, no, that's just kind of like driving around the problem, because now you've introduced this thing of, well, it'll take anything, but you know that that's not the truth, you know, but all you've done is say, hey, compiler, stop telling me there's a problem here, right? And then, you know, when sometimes you have that conversation, it's like, look, you know, this is going to come back and bite you later on. So take the 5 minutes and fix it properly. You know, don't just get it through the code review, right?
Absolutely. And the thing about like, using any or like force unwrapping, again, the test-driven development mindset is not really about writing tests, but like finding ways to get fast feedback and finding automated way to help you do the right thing. So when you specialize your type from any to string or whatever to int, whatever type you actually is the only one that you need, you're moving the test, the check for the correctness of the input from the runtime to the type system. There's an example I make in the book, which is in the context of networking, but in the context of any kind of operation that may succeed or fail. And let's imagine you have a callback. The old way of doing that in the Objective-C days was you would have a parameter with the success value that you might have gotten and a parameter with the error. And then in the code, you would check, okay, if I don't have an error, but I have a value, then it was successful. If I don't have a value, but I have an error, then it fails. And then you had this awkward case in which you didn't have, you could have run code that had no value and no error, or a value and an error. And you would have to write in your implementation something to handle it somehow, right? And if you apply test-driven development, you would have likely written a test for that as well, because you want, okay, in this behavior, it defaults to a value, to a default value or something. With Swift, with the strong type system, and in particular with the enum type, you can describe this mutually exclusive state using an enum. You can have a enum case success with associated value, the value of your success, the type of your success, and the case error that takes an error. And in fact, the Swift standard library has a type for that. It's called result. It's one of my favorite types of all the Swift standard library. And this shifts the code, the check, the test from your code to the type system level, because now it is impossible that you get both a value and an error, because the compiler is not going to let you do it. And that is very, very beautiful, and it saves you time, because now you don't have to think about that anymore. You don't have to write that anymore.
As much as I know, and this is kind of a personal choice that I made, I know that I can mostly trust the type inference system to work for me, but I'll be honest, most of the time I try to make sure that I, assign the types myself, so that when I'm going through, it's not that I'm saying the system's going to get it wrong, but it's so much easier for me when I'm doing other coding and things like that, that it's like, okay, I set this to be a string, and I know that that's what it's going to be. And if it's not, my code is expecting it to be a string. So like you say, I can write a test that says, hey, if this isn't a string, then, test fail, right? Whereas there's every chance that the inference system will get it right for me, but there's also that slim possibility that it might not. And by me forcing the issue, in my code, then I'm okay, because I am going to be either right or wrong. So I'm curious, do you have any thoughts, or do you have a preference? Do you trust the inference system, or do you prefer to put your own types so that code is doing what you think it should be and the compiler thinks it should be as well?
Yeah, good question. I think there's definitely an argument to be made for being explicit about the types. I think that in your example would have been like let value colon string equal wherever the values come from, like clearly specify, hey, I expect this to be a string. Maybe I'm lazy. I just fall back to the least amount of code that I can write. I do know that I don't have any data to back this up, but my understanding of the compiler and the type inference is that there are certain instances in which type inference may become like time sensitive, time consuming, because you have a particularly complicated, convoluted types structures. So the compiler, it takes a lot of time to just infer the actual type that this big blob of assignments and chaining and operation will result into. And in that case, it is useful to really be explicit about it so that you help the compiler. You help the compiler help you, because if you say that you're expecting this string and you have this big complex sequence of functional transformation of your the value that you are syncing from the publisher, the type that comes out of this big transformation is not a string, the compiler is going to tell you. Whereas you might, if you weren't explicitly declaring it, you would learn it later on in your code, that you were setting a string and you got, I don't know, an array of strings instead. So there's a case where I tend to just fall back to getting the compiler to help me.
Okay. Yeah. No, I mean, there's certainly nothing wrong with, the line of code that I don't write won't go wrong. You're absolutely right. And I think that, that's why it's also, like we were saying earlier about, looking foundation. If there's probably a solution for at least part of your problem so that you don't have to write the code and, do some of that, reinventing of the wheel. I think you're right.
I find that go look in Foundation, go look at the docs. I find that every time most of the times I look into the documentation, I find something that I didn't know and surprised me and helps me do what I was trying to do. The hard part is not really the finding the solution, is remembering to go look for a solution into the documentation. Is at least for me is an habit that I need to put more reps into it to develop that automatic reaction. I don't know about this. Let me search the docs instead of just trying to code my way out of it by myself. And the test-driven development way to do this would be, so you have your test, you're trying to make it pass, and it's taking you a long time to make your test pass. And this is in itself is one of the many different type of feedback that the tests can give you. It's like, you should be able to move in small iteration, in quick iteration. Okay, I have the test, I make it pass, and then I refactor, and then I make a change, and the test is red now, and then I make it green. And if it's taking you a long time, you start to become uncomfortable about it, and that is a sign that, maybe I need to take a step back and look at the design that I'm trying to achieve here, or maybe is the time to go look for a solution online, look at the documentation. Maybe I don't have the tools to do what I'm trying to achieve right now, and I need to learn something new. So that is another form of feedback. Is you should be able to move through the red-green refactor flow smoothly. And if that's not the case, then take a step back.
I'm really thankful that so many people like yourself are, standing up and saying, look, testing is important for these reasons, right? It's easy to dismiss testing as not necessary, but it's only really maybe not necessary for the next 2 minutes of the code's life. But then after that, it's super important because you don't have a record of the ifs, whats, and why you did these things. A test, I guess, is it fair to say a test is kind of documenting the code in some ways without writing the documentation for it?
So absolutely. A test is, I see them as a living documentation of the developer's mental representation of what the code does. And I wrote a post about it. There's nothing more insightful than when a test that you expect is going to pass fails. Because that's funny. I wasn't expecting that. And that is an occasion for you to refine your understanding of the system. In fact, I would recommend when you practice test-driven development, try to always guess what the tests are going to do before running them.
Oh, I like that.
Because so that if they don't do what you expect them, then there is an asymmetry between your mental representation of that bit of code or the system of what you're working on and the test. It could be there was a typo. It could be you forgot a bit, or it could be a bug that you discover, or it could be that the code is written perfectly it was just you didn't know how it was supposed to behave. This happens a lot when working in other people's code. Expect it to do something, but it doesn't. And the code is actually doing what it's supposed to according to the spec and the history of the project. Like it is correct. You were on the wrong, assuming that it was going to do something different.
That's a really good point and a really good tip, because that instant kind of red flag of, well, I expected this to pass because I wrote this code that would have passed it, and then it doesn't, is either one of two things, I guess, right? Either one, I wrote the test wrong, which seems less likely than the code that I expected to do something didn't, and it's just pointed out to me now before I hit the run button, built it, compiled it, run it on a device, and it blew up my application, because this test is saying, hey, you may think it's going to do this, but that's not what's going to happen. And that's a really good point right there. I think, the takeaway here has to be write the tests, trust the tests. They're not 100% of the solution, but I'm thinking of a test as being, that extra developer looking over your shoulder and saying, are you sure? Do you really want to do it that way? Or that's never going to work. So that's a good point.
So some people refer to the test to an extent, but in particular, the compiler is like a silent pair that is doing pair programming with you all the time, and they're never wrong, or like they're 99.9999 times correct. So there's some that you wanted to do that, but that is not going to work.
Yeah.
And even if you try to do that, if the compiler said that it's not going to work, it ain't.
All right, Gio, thank you so much for joining us today. Please, please, please tell everybody where they can find the book. Give us some details on the book and where they can find you to reach out if they want to have a conversation with you. Please go ahead.
You can find more about the book at tddinswift.com. That's tddinswift.com. The book should be out on the 23rd of June in the print version. That might depend on where you live, because of shipping and coordination abroad. The ebook version should be out on the 3rd of July. I'm not sure why they don't come out in sync. The publisher has a reason for that, but I haven't dug into it. But it's going to be out soon. If you go on the website, tddinswift.com, you'll find a sign-up form where you can sign up to learn more about it. And I haven't put them up yet, but I am going to send some insights and some articles through that list, so some bonus content to, share some useful information about testing and TDD. You can find more about me at gio.codes, gio.codes. In that page, there's all the links to my other personas on the internet. Or if you want to get in touch real quick, you can find me on Twitter at mokagio. That's MOKAGIO. And I mentioned that I work for Automatic. We are actually hiring. So if anyone wants to work on products such as WordPress.com, Tumblr, and all those other mobile applications that we work on, and they're keen on working in a distributed company that is really puts a lot of emphasis on being inclusive and having a good work-life balance, get in touch and I'll tell you more about it.
And we will put links in the show notes for all of these. So, Gio, thank you so much for being on the show. I really appreciate your time today. And, very excited to see the book come out. Wish you all the best with it.
Thank you for having me, Peter. Thank you for your kind words. And thank you to everyone who has been listening to this.
So I hope this episode has been helpful. If it has, please follow, tell friends about it, subscribe. I would greatly appreciate that. And if you want to, you can go to buymeacoffee.com/PWCOM and just say thank you there by buying me a coffee, because I really love my coffee. Take care. I will speak to you in the next episode.